Hello, my name is Maureen and I will be presenting on big data. So to start off, we kind of need to know what big data is. So big data is defined as the massive volume of data that can either be structured or unstructured, but it is very large and so large that it is difficult to process using existing traditional database and software techniques. So there are about three components that kind of make up big data, often referred to as the three V's of big data. We have volume, velocity, and variety. They're pretty straightforward. And to start off, we have volume. Volume is just the large amount of data, and this can be seen in terabytes, exabytes, which are 1 million terabytes, or petabytes. Next, we have the velocity, and that is just the speed of generating the data. And then we have variety, and this is just refers to the types of data. There is structured, semi-structured, unstructured, textual, and graph. And there's also many more outside of that, but those are just some examples. So the concept of big data comes largely from the growth of the web. So some past sources and uses of big data came from weblogs from like the server. So they had many different uses. Companies had many different uses for these weblogs. Companies would use the information to decide what info to present to users and to engage them more to the site, which would ultimately enhance the user's experience. This information will be used to decide how a website should be structured, which basically means how can we as a company make it easy for most users to navigate this site and to find information that attains to them. This information would also be used as a determining factor. So it would determine user preferences and trends based on page views. And by using these preferences and trends, it helped manufacturers or vendors know what to produce more of or less of. And lastly, this information was used to display advertisement and click-through information. So click-through is when a user clicks on an advertisement to get more information, and then conversion actually occurs when the user purchases the advertised product or the service. Companies actually will benefit highly from these two, and they often will gain money if users perform these actions. So some more present sources and uses of big data comes from mobile apps, the data from mobile apps, data from transactions, whether it's online or offline. So I think of things like Amazon, data from sensors, the Internet of Things, things like Alexa would be, I believe, an Internet of Things. You kind of program that. Maybe like a smart fridge would be that as well. Then we also have metadata from communication networks, such as traffic. They could also be data from like voice networks as well. So querying big data. So SQL, which stands for Structured Query Language, is widely used for querying relational databases. But however, there are probably many more better options that can handle a larger variety of data types and also volume. So there are kind of applications that are used that support SQL plus also support very high performance by running on many machines. And those are transaction processing systems, and those require high scalability. Then there is also query processing systems that also need high scalability, but they also need to support non-relational data. So to start off, we have transaction processing systems, and these support many short running queries and updates. They are also much easier for a database design to support these types of systems. They can manage without full database support, and their primary mode of data access is to store and retrieve data with an associated key. Secondly, we have query processing systems. These are systems that can perform analysis on logs generated by web servers and other applications. So that's just an example of such systems. And another example would be systems that document and knowledge storage and indexing systems. So there are systems that are specifically designed to store, manage, and retrieve big data. And I will be going more into depth on all four of these types of systems just in a second. But just to list them, we have distributed file systems. We also have sharding across multiple databases. We have key value storage systems. And then lastly, we have parallel and distributed databases. So distributed file systems, so I would just go to the next one just so I can better explain that to you guys. So to start off, distributed file systems are systems that store very large amounts of data and data that can be stored across a number of machines. This data, the files, they're broken down into multiple blocks. These systems also support a very large number of concurrent clients. They are ideal for storing unstructured data, so such as web pages, web server logs, images. They could also be used as a storage layer for systems that support storage of records. Generally, file systems that are distributed support sort of a directory system, and that is, those are, systems that have a hierarchical organization of files into directories and subdirectories. These are systems that support mapping, and these are systems that also have the ability to store and retrieve data from the blocks with a specified identifier. So the second types of systems, we have sharding. So sharding is defined as the partitioning of data across multiple databases or machines. Partitioning is done on one or more attributes, and these attributes have a couple different names: partitioning keys, shard keys, or partitioning attributes. A user or an account identifier is one of the more commonly used objects as a partitioning key. There are two ways shard. There's range to partition, there's range partitioning, and then there's hash partitioning. So range partitioning is defining a range of keys that each of the databases handles. So one database can handle key 1 to 10,000, another 10,001 to 20,000. So that's basically sort of how it works. And then there's hash partitioning, and this is computing a hash function that maps a key value to a partition number. So when sharding is done in application code, when sharding is done in application code, the it must keep track of which keys are stored on which database, and it must route the queries to the appropriate database. The application will read the data from multiple databases and compute the final query results. Next, we have key value storage systems, and these systems kind of provide a way to store or update a record with the key, and they also retrieve a record with that key as well. They are parallel key values that store these keys across multiple machines and route updates and lookups to the correct machine. They support replication, and they ensure their consistency. These parallel key values can also add additional machines when required. And importantly, they ensure that load is balanced across machines in a system. And then this kind of makes key value storage systems the most widely used above sharding. There are some companies that will use key value storage systems. Some of the examples are Bigtable from Amazon. There's Cassandra from Facebook, MongoDB, and then one that most people are familiar with is Azure Cloud from Microsoft. So, why store key value? Why use key value stores? A big reason is that their ability to handle, they have a great ability to handle large amounts of data, as well as queries of that data by distributing the work across a cluster, sort of like a group consisting of large number of machines. So this kind of goes back to these key values ensure that the load is balanced across machines in a system. But key value stores, the records are divided among the machines, and each machine will store a subset of the records and processing lookups and update those records. One interesting thing about key value storage systems is that they're also called NoSQL systems. And this is because they are not full-fledged databases. They don't provide any of sort of the standard features that we see in database systems today. So they don't support declarative querying, like using SQL. They do not support transactions. Key value stores typically do not support retrieving records based on selecting a non-key attribute. And I guess an important reason for not supporting these features that we see in standard database systems is that some of these features are not very easy to support on these very large clusters, the very large groups of individual machines. So originally this was seen as something that would be a benefit, but the limitations of key value stores has proven to be a lot. So many of them have evolved to support the standard database features that we all know and love. So lastly, we have parallel and distributed databases. So these run on multiple machines, and they're designed to store data across all of these machines and to also process large queries of that data across multiple machines as well. So data is replicated across many machines to ensure that data is not lost even if failure occurs. So I think this is a very important point. With data, we want there to be consistency. We want data to be accessible, and sometimes, networks fail us, technology fails us. So, but we want to ensure that that data will be accessed even if a failure occurs. And these are what parallel and distributed databases really ensure. Okay, I think that is the end of my part of the presentation. And then the next would just be Adam and Shelby presenting on their part. Thank you.